So this is 5.3b in college trig. We're still working on sum and difference identities for cosine, and we're going to look at some cofunction identities here. And there's a table there. So remember cofunctions. We did those in lesson 2.1, where you have the sine of, say, 60 degrees. That equals the cosine of 30, because 60 and 30 give you 90. So that also works for tangent. Tangent of 60 would equal the cotangent of 30, because they add up to be 90. And so the same is true when you're doing these with pi over 2 when you're in radians, so just something to keep in mind there. Alright, so let's go ahead and look at example number 2. They give us, find an angle that satisfies the following. Okay, so they give us the cotangent of theta, and that equals the tangent of 25 degrees. So what they're looking for is this angle right there. What angle makes the tangent, or makes the cotangent equal to the tangent at 25 degrees? Well, it's really easy to do. We just look up here in our handy dandy little table here and see that cotangent equals sine of 90 minus theta. So we're going to get rid of the cotangent and substitute that in its place. Okay, so that equals the cotangent, and I'll leave my tangent on the right hand side alone. Okay? When I have tangent here and a tangent there, nothing added or subtracted to the tangent, if you notice it's multiplying, I can kind of do the same thing I did with logarithms. I just make it go away, because they cancel each other out. So now I have 90 minus theta equals 25, and then I'm able to find out what theta is, and theta ends up being 65 degrees. 90 minus 65 is 25. So the cotangent of 65 is the same as a tangent of 25, because remember the difference between, if you add them up, you get 90 degrees. Alright, let's look at the B portion of this. See, these aren't too terribly bad, especially when you come off lesson 5.1 and 2. Alright, so we have sine of theta, and we're saying that equals the cosine of negative 30. So again, we look up here at our table. There's the sine of theta, so I'm going to replace that with cosine 90 minus theta. Cross out my cosines. Solve for theta as if it were a variable, because it is, it's just an angle. Okay, subtract 90 from both sides if you want to go through the whole math here. And I have negative theta equals negative 120. Negative on both sides make it a positive. We get an angle of 120 degrees. Okay, so the book solves this one way. I'm going to solve it another way. And you can use either way. Doesn't really matter. I'm just doing it a different way because it stays more consistent with what we did for A and B. Okay, so we look at our secant. Secant equals this. So we're going to replace secant with cosecant, 90 minus theta. Okay, notice this here. We're in radians here. We're given a radian angle, and I can't use a regular degree angle there. So I'm going to change my 90 degrees to pi over 2, because that's a 90 degree angle in radians. Okay, cross out my cosecants. Now I'm left with just that. In fact, I can take my parentheses off here. And to get rid of the pi over 2, I subtract that from both sides. So this is going to be 3 pi over 4 minus pi over 2, but I need a common denominator. I get that, equals negative theta. Okay, because that went away. This here, 3 pi minus 2 pi is 1 pi over 4 equals negative theta, and make that a positive and that a negative, and I get negative pi over 4. So that's the way to do it, very similar to the way we did examples A and B, and I don't know why they did C differently, but you can look at that and see how they did that if you'd rather try that method. Alright, so let's go down to example number 3. So example 3 says that we're going to write the cosine of 180 degrees minus theta as a trig function of theta. So basically what that means is we don't want it written as the difference of two angles. We just want it written as one. Okay, and when it says a trig function of theta, that means theta is going to be in the answer. So we're going to look at the cosine of a sum or difference, and we're just going to rewrite this as the cosine of 180 times the cosine of theta plus the sine of 180 sine of theta. So we took this one right here and wrote that. So I know the cosine of 180 is negative 1, and I don't know what theta is, so I just have to leave that. I know the sine of 180 is 0. 0 times anything is 0, so that goes away. So we have negative cosine of theta left. So this actually equals that. And that's what we were doing. We were writing it as a function of theta instead of having the 180 in there as well. Okay, last example, example 4. Suppose that sine of s is 3/5 and the cosine of t is negative 12 over 13, and both s and t are in quadrant 2. Alright, so that means we've got one triangle there. We'll call this S, and this is opposite over hypotenuse, so we have 3 there and 5 there. And let's look at the cosine. That's a completely different angle, so I'm going to make it different here, and we're also in quadrant 2, and this is adjacent over hypotenuse. So this is going to be negative 12, and this will be 13. Okay, so this will be angle T, and this will be, whoops, let me stick with my color here. This will be angle S, okay, which will be the same as the one inside the triangle, but anyway. What we're going to do here is rewrite this as the formula, because they say find cosine of S plus T. Well, if that's true, I'm going to follow this right here, and that's going to be cosine of S cosine of T minus sine of S sine of T. Okay, so I'm looking at each of these 4 pieces there. Alright, so it says find the cosine of S. Well, I know the cosine of T is negative 12 over 13, but they want the cosine of S up here. In order to find the cosine of S, that equals adjacent over hypotenuse. Well, what do I have over here? I've got the hypotenuse, but I don't have the adjacent here. So I'm going to have to use Pythagorean in order to find out what that is. And when I use Pythagorean, I find out that the adjacent is 4. And that's one thing you can do. You can just know off the top of your head. When you have a triangle, and you know 2 of the sides are like 3 and 5, the other one has to be a 4. This is called a 3, 4, 5 triangle. And that will always be the case. If this is 3 and that's 4, then you know the hypotenuse is 5. Or if this is 5 and that's 4, you know that the shorter one is going to be 3. Okay? Or a multiple. This could be 6, 8, 10. So any multiple of these. So that's why it was so easy for me to come up with what that was. So now that I know that one, I know that my cosine of s is going to be 4 over 5. Okay, so I'm going to keep that handy because I'm going to plug that in a minute. Now I need to find the cosine of t, and we have that up here. We were given that because I'm looking at this part right here, and that's negative 12 over 13, so I'm going to keep that. Now I'm going to look at the sine of s. So I'm going to look for the sine of s. So I'm going to look at the top triangle. Well, I was given the sine of s up here at the top, and it says that it's 3/5. Okay, so I found, at this point, let me show you in green here, I found this, I found this, and I found this. So now all I have left to find is the sine of t. So, put it in white here, sine of t equals opposite over hypotenuse, and I'm looking down here at the bottom triangle, because this is my t, opposite over hypotenuse. So I need to use Pythagorean again in order to find opposite. So 12 squared plus x squared equals 13 squared. I go through all the work, and I find out that the sine of t then is, I think, 5 over 13. Alright, so now I've got all 4 of these. So let's go ahead and see if we can move some stuff around. I keep running out of room to write. See if we can get this graph out of the way. Yep. Okay. Alright, so let's go ahead and look at my problem again. It says that the cosine of s plus t, so I'm using this one, it's going to be the cosine of a, times the cosine of t, minus the sine of a, or the sine of s, 3/5, times the sine of t, which is 5 over 13. Now I just do the math. 48 over 65 minus 15 over 65. And I did find a mistake here. This is supposed to be a negative 4/5. Let me draw it here again. Remember, we had this is 3, this is 5, and we found this one to be 4. That's a negative. The x is negative in the second and third quadrant. So, sorry for that. That should be a negative right there. You probably caught that, and I just didn't. So now as I'm looking at this, this should have been a negative. These two multiplied together should have given me a positive. Okay, so now I'm on the right track. So that gives me 33 over 65 for my answer then. So that is what the cosine of s plus t is. And that's it. If you can work your way around my mistake there, my negative mistake in example 4. And as far as the problems, you're going to basically do everything the exact way that we did in the exercises. I'm looking through here. It doesn't look like there's anything psycho or weird. 27 to 32, you're filling in the blanks. So if the cotangent of pi over 3 for 27 equals blank pi over 6, well, pi over 3 plus pi over 6 is going to be a 90-degree angle. If you were to add those together, you would get 90. And so that means they're cofunctions. What's the cofunction of cotangent? Tangent. So you would just do that for each of those, and you should be good to go there.